So in this discussion, I'd like to go over identifying the components of a typical modern forced air furnace and also the sequence of operation. To begin with, the 24-volt room thermostat, which is located on the side of this machine, this demonstration machine here, will send 24 volts to our integrated furnace control board here. As you can see, it has several relays on it to be able to control the various operations of both the heating and cooling system. The main thing I wanted to identify to you on this board is the high voltage rectifier for the furnace. That's this circular device that you see here, and what that does is it takes the 24 volts that's applied to the circuit board and steps it up to a very high voltage, anywhere from 7,500 up to 10,000 volts AC. Yes, it's a high voltage, but it's very, very low current. The AC current is sent through the orange wire here over to the furnace side, over to the spark emitter. The spark emitter acts just like the spark plug inside of a car engine and creates an arc of electricity between the probe that is in there and to the burner. So there's actually a high voltage arc of electricity that will jump from the probe that's inside there over to the burner to ignite the natural gas. But the very first step in the sequence of operation after a call for heating is our IFC, our integrated furnace control board here. The first thing it does is one of the relays on the board energizes the inducer fan motor, which is located here. This is our inducer fan motor. It's just a simple shaded pole motor, and it comes on and starts spinning and inducing a draft through the intake of the burner and draws the natural gas and the flame through the heat exchanger positively, and the flue gases are rejected here out of this hood here. So the very first thing that happens is the inducer fan motor comes on. The second thing that happens in the sequence of operation is the inducer fan motor is proven by an air pressure switch. This is a normally open, close on change of pressure switch, and it's got a separate loop of these two yellow wires here going back to the IFC to tell the IFC that the inducer fan blower motor is running. It is very important that we prove that this is turning and pulling air through the heat exchanger before the ignition process. Otherwise, if we don't have the proper airflow through and we do the ignition process, we might have a flame rollout situation where the flame would actually come backwards out of the heat exchanger trying to seek oxygen, and it could damage our components in here. So that's why it's vital that the first step before the ignition process is to prove that this inducer fan motor is operating. After we've proven the inducer fan motor is operating, the next thing that happens in the sequence of operation is that high voltage is sent to the spark emitter, so we have the high voltage arc, and the next thing that is happening is the gas valve is then energized by the IFC. It sends power, I believe, through red and blue, or red and purple, or red and green, pink and green wires going to the gas valve here. So once we've proven that the inducer fan motor is moving, we got ignition from the high voltage rectifier, the gas valve is energized and gas flows through the manifold to the orifices that inject the natural gas into the burner assemblies, and the flame is drawn into the heat exchanger behind this wall, and the indoor fan motor on the other side of the machine blows the air from the return air duct through the heat exchanger and then across the evaporator of the cooling side of the air conditioner and around over here to the supply air duct. So if you look around over here, you can see this would be our supply air, and this is our return air. You can see the indoor fan located there in the return air side of the machine. It's sucking air in this way, blowing it across the heat exchanger, and then the air is forced across the heat exchanger, across the evaporator, and into the building through the supply air duct. So then the next step of sequence would be simply the room thermostats get satisfied. We've reached the desired temperature in the building or the area that this machine serves, and the gas valve is de-energized, the flame goes out, the indoor fan is both delayed on and delayed off by the IFC. The indoor fan is always delayed on a furnace to give the heat exchanger a chance to get warm so that we get nice warm air into the building upon startup rather than creating a cold draft. And then the indoor fan is always delayed off so as to give the chance for the heat exchanger to cool down. And also we're making use of that heat energy and putting it into the building where we want it rather than letting it to escape to the environment. Another thing I want to go across while we're talking about these components, we've identified the high voltage spark emitter here, and it ignites the burner as discussed. But that process also has to be proven for safety as well. In these modern furnaces, they are now proven by what's called flame rectification. Flame rectification is the fire actually rectifies the high voltage that's being sent through the orange lead to the spark emitter and conducts it through the flame to the flame sensing rod. This second rod in here that this red wire is connected is the flame sensing rod, and what it's doing is it's receiving a high voltage DC, pulsating DC, and sending it back to the IFC, and that proves that we have ignition. That's also another safety feature that we have to do in the process of the overall sequence of operation in a furnace is to prove that the gas is being consumed by fire and the gas is not just accumulating in the heat exchanger and turning our furnace into a potential bomb. So the ignition has to be proven. The modern way of proving flame or proving ignition is through flame rectification. The high voltage AC current is actually converted to a high voltage pulsating DC current by the fire. The fire actually conducts electricity because of all the carbon atoms that are in the flame. Carbon exists in the oxygen, in the air that's being consumed by the flame, and carbon also exists in natural gas. Carbon exists in every substance that we're aware of. So anyway, that is the overall of the sequence of operation and identification of the main components of a natural gas furnace in modern air conditioning systems.